All right, well, let's get cooking. Now it's 1 o'clock. Well, thank you for coming after lunch. This is Containers, You Better Get On Board. That's a metaphor, right? It's supposed to be funny. That's me. I'm Anthony Nocentino. I'm a consultant and trainer, founder of Nocentino Systems. I like to work on computers a lot. I have some contact information up there for you. It's going to show up again later. I'm on Twitter pretty frequently, probably more than my family likes me to be on Twitter. And then also I blog, and I'm also a Pluralsight author. I have some free cards up here for you guys to get access to that content. So this session is going to be fun, and it's going to be fast. But do ask questions throughout. But we're going to cover tons and tons of material. I know we're going to talk about what a container is. So if you've never used a container before, that's cool. We're going to start from zero and build you all the way up. We're going to talk about the container universe. There's lots of buzzwords out there, things that are maybe new nomenclature and technologies and things like that. Just kind of give a quick landscape on what's going on out there. Then we're going to cover two bases. We're going to cover deploying SQL Server as a container and deploying and running PowerShell in containers. Kind of give you a sample of what a stateful application looks like and what a potentially stateless application looks like. And you can see kind of the bits and pieces and how that comes together. And then we're going to do lots and lots of demos. You guys are going to get all of the code, and hopefully by the end of today, you'll be able to go and run this stuff on your own. And then we're going to talk about the need for a thing called container orchestration. You'll find as we build these constructs in our container world that, well, it gets to be a little unruly because of this whole microservices architecture-y thing. And we'll learn about why container orchestration is needed and the problems that it's solved. I tried to get this down to all demos. It was really a lot harder to do than I thought it was. And so there are about 10 slides, mostly pictures. And we'll walk through those to kind of nail home some concepts with regards to how this all pieces together. So we're about 50% demos when it comes to wall clock time. And so when we're working or introducing containers, how many people know what a virtual machine is? That was like, yeah, all right. I have a really dry-witted humor, so let's just go with that. So we're talking about a different level of abstraction now, right? We're not going to be working with machine virtualization in terms of CPU disk RAM. We're going to be working with virtualizing the operating systems and the services that it provides. How many people are familiar with what a system call is inside of an operating system? Anytime you have to ask the OS to do something for you, you basically to interact with hardware in terms of CPU, disk RAM, anything, make a network call, that's a system call, right? And effectively that's I wouldn't say the unit of abstraction or virtualization for a container, but it is. As long as you can respect what's called the system call interface, your application or the underlying OS can respect that interface for your application, you can put it in a container and run it anywhere, right? And so you have this concept of a shared kernel and system resources. The kernel in most operating systems, all, is in charge of the hardware, right? It's a privilege mode, execution, things like that. So what does a container contain, right? A container is a thing. It contains the binaries, libraries, and file system components that are necessary to run your application, right? So literally the executable, any of the supporting stuff to run that code, whether it be DLLs or libraries on Linux, things like that, packaged all together with any additional file system constructs that you need, like database configurations, database files, or whatever it needs to get it up and running, right? That's all packaged up as a unit, and you can deploy that thing. And so generally speaking, when working with a container, I told you it was going to be all pictures. I clearly am not telling you guys the truth. But because it's all bullet points right now. But anyway, generally speaking, you have one application inside of a container, right? And we're going to work with PowerShell. We're going to find literally that is the only thing that's in there, right? And that's going to be conventionally the only thing that you have inside of a container. We'll look specifically at SQL Server, look at its architecture for a second. We'll find that there are multiple processes running inside of an individual container. But this is the unit of work. This is the concept behind microservices architectures. Containers are also ephemeral in the sense that we really don't want to maintain any data persistency inside of the container, right? Because we want to be able to take this container, throw it away, and deploy a new one for that application. And we're going to learn about those techniques as we go through today. So for a cool picture, this effectively is what a container will look like for the rest of this presentation, right? Is our application, the binaries and libraries that support it, and any of the file system stuff that you need to run your app. And so let's start off with a comparison. This is where I want to beat up on VMs for a little bit. So back in the day, people used to buy computers and put them in data centers, right? Now we just swipe a credit card and buy VMs from somebody else. But you would buy a physical machine and you'd install a hypervisor on it, right? And then you'd go about installing these guest operating systems on top of that, and then you install your apps on top of those OSs, right? And this is cool, this works great, but there's a couple things from an efficiency standpoint that we gained and didn't gain. What did we really gain by doing this from a resource standpoint, right? We gained better utilization of hardware. What's really, really cheap in your data center? Hardware, right? Our time isn't. And so we still get stuck dealing with all of these operating systems independently in all of these applications. If something goes bump in the night, what do we have to do? We have to put our cape on, figure it out, and bring that server back online, right? And that was very time-consuming operation inside of IT ops and how we roll out new code and new configurations. We have to manage this stuff over time, and what we're expensive, computers aren't. And so I like to say that this architecture is high maintenance. I usually get beat up on this one a little bit on Twitter afterwards, but I think it's high maintenance, and there's a better way. And so let's look at potentially what I think is a better way to deploy applications. And so in containers, we can have either a physical or virtual machine be the underlying substrate of our platform, right? We install an operating system. People still do these things. We install operating systems on top of hardware. And then with that, we can take that thing that I talked about earlier, the container itself, and we can deploy that thing on top of this hardware and do that over and over again for different applications. Now, what's interesting about this architecture is that there's essentially with some process isolation going around this individual application. So application 1 and application 2 know not of each other on top of that host operating system. In fact, if they need to communicate, they need to communicate to each other over the network, right, to exchange regular IP datagrams or whatever it is to exchange data, right? And so in that case, we also escape a concept of DLL hell, right? In fact, that I can have my binaries and libraries in app 1 totally self-contained within that unit, and app 2 totally self-contained within that unit. So we no longer have to deal with conflicting libraries and things like that when we roll out our applications. So I like to think that this is lower maintenance, primarily because of one thing. We can, when it comes to dealing with patching, deployment, and whatever, this really brings to home the kill it and redeploy it philosophy, right? We can simply kill our container as long as we're maintaining the state of our application externally to the container and redeploy it, right? And that thing gets into this whole concept of immutable architecture because the container images are effectively read-only, right? And so if we can start our infrastructure from a fixed point in time at any time, then we know we can stand our application up simply by killing it and redeploying it, as long as we maintain the state of our applications externally, things like databases, session state, things like that, right? We just have these worker bees that are doing this stuff for us for our applications. It's cute, isn't it? Oh, man. So the container universe. So this is the Docker whale. It's easily the coolest icon in all of IT. I mean, it's adorable. Except when it crashes on Windows, when it crashes, it gets a little Band-Aid to the right of its eye. It's really, really, really cute. Except I've only ever seen that once when I had a 9-month stint with a Windows box. I'm back and I'm recovered. So Docker, sorry guys. So Docker is a technology, right? And Docker Inc. is a company. In the sense that like Red Hat is a company and CentOS is a thing that's a technology that's, I guess, consumed by the community and developed. So in this sense, Docker being a technology was kind of manifested by Docker Inc. originally and then open sourced about, I think, 2 years ago. And so Docker, the technology, is now, I believe it's called Containerd, but don't quote me on that yet. But Docker Inc. still exists and provides the ecosphere around what Docker is. And so we have this management system that instantiates all the isolation and things that we talked about in the beginning and manages that for us. Docker is cross-platform, Linux, Windows, Mac, and things like that. But it's not the only fish in the sea. There are other container engines out there, or container runtimes that are available to us. Rocket, CoreOS, Windows has a container runtime built into it, I believe in 2016 and greater. And if you're familiar with what a Che-root jail is from like the late 2000s, or late 90s, early 2000s in BSD, similar concept, process and file system isolation. Thank you for nodding on that one. And so effectively a similar technique. So Docker Inc. being the company, they make stuff, sell you stuff. You can call 1-800-Docker when things go wrong. But in the end, all of this stuff is open source now and available for us to consume freely. So it talks about consuming things like getting containers. And let's go through kind of the pipeline of how containers come to exist and how we get them to consume them in our applications. And so a container image is the thing that I showed you earlier, the box with the code, the runtime, the libraries, and also environment variables. So that's how we assert configuration generally upon a container at runtime. Container starts up, looks at the runtime variable, your application looks for these variables to configure itself and then goes, right? And so you get out of the business of statically configuring stuff inside of a container and you do your best to store that externally. Registries are where containers live, right? And so we have things like Docker Hub and Azure Container Registry, and now Microsoft Container Registry, and your own. You can build your own internal container registry to consume containers. And then there's this thing called a Docker file. The Docker file basically describes the image itself in the sense that what program do I load when I start up this particular container? What are the environment variables that I want to inject? Are there any network ports I needed to open? What are the file system constructs I need to respect in terms of volumes and things like that for data persistency? And so if you're a developer and you're sitting down and you want to containerize your application, you're going to start off with compiling your code, building a Docker file, and constructing an image, right? So the Docker file comes along, you put all of your applications, your binaries, in the Docker file in a single directory, and you do what's called a Docker build, right? That takes this thing, it turns it into a binary image that you push into a registry, right? That registry can live locally on the internet, wherever you want it to be. Then when you want to run a container, you pull the container down onto the host OS and instantiate that application or that container and start it up. Generally speaking, I'm not in the business of making containers because I consume containers from other people. I'm not a developer, I'm a systems person. So when we're talking about like SQL Server and PowerShell and things like that, Microsoft is doing that for us, building and pushing the containers, and then we consume it by doing a pull, right? We pull the container down and instantiate it on our operating system. And so when you look at this from an OS level, a container is nothing more than a running process. It's just with this little shell around it that we're going to look at a little bit later when we get into the demos. So data persistency gets to be unique inside of containers because it's a critical thing. I don't want to store data inside of the container because I want to be able to pick it up, throw it away, and redeploy it, attach my data, right? And so I can move forward if I have program state or information that's stored externally. So yeah, what about my data? And so I told you you'd see this picture a lot, right? That application is a very, very useful application, app one. So containers, generally speaking, are read-only. Not generally speaking, they are always read-only. And when you write data inside of a container, even when you start it up, right, you generate log, you do these things, that's going to get written to what's called the writable layer of the container. The read-only layer and the writable layer, unified together, become the actual running file system. And so as you change data, that's where it lives. But that's inside the container. It's part of the run state of that container that you're going to be working with. And so if you delete it, that data is gone, right? It's no longer part of, your data is gone, and it goes away. So we want to do better. We want to leverage a thing called a Docker data volume, which is a Docker managed resource that's completely independent of the container. And so we get into a situation where it looks like this. We're going to be consuming volume from the underlying OS and mounting that inside of our container. So we get into the business of where I can just kill off app one and reattach volume one in that same exact location and go about my day running my app. So running PowerShell in containers. I felt like I had to talk about PowerShell at least once, right? So what's the vision for PowerShell core, right? If you've seen Jeffrey Snover talk or Joey Ello, you know what the vision is, right? They want to run it everywhere, right? In a good way, not like a weird like bomber kind of way, right? and so they want to run PowerShell everywhere. Now, thank you. What if we wanted to, now we get into this situation, what if we could run whatever version of PowerShell we want it to run anywhere, right? And again, wherever we want it. And we can do this as a container, because I'm going to show you later, there are hundreds of iterations of PowerShell available as containers today. Who's worked with a PowerShell container yet? Cool, about half of you guys. Now, what if I wanted to arbitrarily run an application just somewhere in my data center? I just wanted to throw some work in my data center, run a script, and have it go away, right? Nowadays, you have to stand up a VM and go through all those gyrations to get that thing going, or run it on your workstation or not. So if we had that ability, right, if we had the ability to run a script arbitrarily and just throw it in our data center somewhere, execute it, and it goes away, it sounds like serverless, right? Well, chances are that's how serverless architectures are built, behind the scenes. And how can we orchestrate that work, right? How can I say, well, I want to run this script in this kind of container somewhere inside of my data center, right? How do we handle that? Like job distribution. And that's where container orchestration is going to come in, and we're going to look at that later. And so we'll close that loop towards the end of the talk. And certainly, through the first couple bullet points here, it's kind of like, vision, like forward-looking stuff, like I can arbitrarily run whatever I want, wherever I want. But of course, in testing scenarios too, right? I don't have to have multiple versions of PowerShell installed on my machine or have multiple machines available to me. I can consume a container on whatever platform, whatever version of PowerShell core that I want, right? 6.0, 6.1, 6.2, 6.1, 6.2, RC1, whatever is coming in the pipeline. So SQL Server, this is going to be our stateful application that we're going to look at today when we compare it to running something completely stateless, like when I talk about PowerShell. So why would we want to run SQL Server in a container? Because I can deploy SQL Server in a data center in about 10 seconds now in a Docker container, right? Which is bananas if you think about it. I can also upgrade SQL Server in about 3 seconds, and we're going to do that in a demo. The absolute #1 best that I've ever done with DSC to deploy SQL Server is about 2 minutes on like really, really fast SSDs, right? Absolute best. I mean, it's nice, it works, it's Windows. And that wasn't a jab, that was actually a valid point. And so because of this, there are Windows and Linux containers available, but you cannot use, this is the link to get to the Windows Docker container, but you can't use Windows in production because the SQL Server team doesn't support that. We can only do that on Linux. Take note of that for reasons. So demos, cool. We're going to do a lot of demos. We're going to pull an image, we're going to run a container, we're going to access the application, so we'll talk a little bit about how networking pieces together inside of our container. We're going to connect to it, we're going to persist data, so we're going through Docker data volumes and things like that. And then we're going to talk about passing commands and scripts into PowerShell containers, and we're going to use some buzzwords because it sounded cool, right? Serverless, function as a service, and things like that. And we're going to pretty much, by the end of this, be able to have our own serverless platform that we can deploy in our data centers. 4 minutes. Hold on, I want to cover one more slide that I cut out that I think, no, we'll talk about that later. So here we are in VS Code. I use VS Code, it's cool. And we're going to set an environment variable because I'm going to use this password a whole bunch throughout the demos. And this will be zipped up and made available to you by the end of today. So when we want to consume a container, we talked about that pipeline of pushing and pulling and things like that. And generally speaking, I'm going to pull a container from a registry. And so we install Docker, and we get this command Docker. We get this verb pull, and we tell it Docker what we want it to pull. We want to pull it from a specific container registry. This one's being pulled from mcr.microsoft.com, which is Microsoft's container registry, so that's where they deploy all of their assets. If you were working with something from a Docker Hub, you can omit the registry and just say Docker pull nginx, or whatever container it is that you want to consume. In this case, at the end here, we're pulling the MS SQL Server container with this thing on the end here. It's called a tag. Right? A tag represents basically an image inside of the registry that you can consume, so you can say, I want this one. Right? And so let's go ahead and do that. Let's pull this container. And because I don't trust conference Wi-Fi's, I already pulled it earlier. And so Docker is smart enough to know, because of this thing called a digest, that it already had that container. It runs a hash over the binary stream, pulls it down. It's like, hey, I got, and the image is up to date, right, for the 2017 latest container. Now, when we want to know what kind of containers are available, we can go to a website and browse it, but why would we ever do that, right, when we're talking about working in PowerShell and things? So I'm going to switch over to PowerShell core. My buddy Andrew Prusky came up with this bit of code. I can go and I can ask the container registry for all of the images with all the tags that are available for it. So I can say, I want to use this version, that version, whatever version is, and I simply take that and I specify it in the Docker pull, and I can consume it. So let's get out of here. Once you pull your image down, like I said earlier, it's cached locally. So these are the collection of images that are on my machine, right? And so you can see SQL Server specifically is only 1.38 gigs. What's the absolute smallest SQL Server you've deployed in your data center? Probably 60 gigs, with Windows and all that fun stuff. And then you have data to actually store, right? That's not the case. 1.5 gigs. They might have left the debug stuff on that one, right? Because it's CTP in 2019. And so when working with tags and images and things like that, you can see that we have our repository where it came from, with the registry. I don't know why it says repository there. And those have tags. And so this is how you would address the individual containers themselves. But if you notice, a couple of these have the same IDs. These are the same images. One of which is, let's go with this one, the PowerShell one, is on 6.2 Ubuntu 18.04 and latest. So that is the latest version that's available or tagged with latest by the team. And they maintain that and update it with the latest one. So that's the exact same image from a binary standpoint on my machine. Same applies for these as well. If I want to go into the container, Docker this inspect command is probably going to become a very useful thing to you. It's one of my favorite commands. You can combine it with what resource you want to look at, and you get a ton of data. So we're going to say docker image inspect, mcr.microsoft.com. I'm going to specify that all the way out the container, pipe it in ls because it gives us tons and tons of stuff. We see the container ID, the repo tags associated with this container. We also see, we go a little bit further down, exposed TCP port. So effectively, this is a JSON version of the Docker file stored inside of the registry that we can consume. And so this is describing what this container looks like and how it starts up and any things like environment variables that have to be set. So here we see environment variables, and this is the command or the entry point, and this is the actual executable or the process that starts up when I say, hey, start this container, right? And so let's do it. It only took us 25 lines of code to get to actually running the container. So when you want to run a container and actually get it up and running, we say docker run, and I'm going to inject some configuration now with environment variables. This is a very critical piece of functionality because of the statelessness of the container itself. I'm going to accept the EULA because Microsoft said so, and I'm going to set an SA password and just pass it in as a variable. I'm going to give it a name, and then I'm going to define a port. So within that process, or within the isolation that is a container inside of the OS, inside the app, SQL Server still thinks it runs on 1433, but it's Docker's responsibility to take that and bridge that onto a real port on the real wire. So in this case, I'm going to take 1433 inside the container and expose that to 1433 outside the container so other people can hit this machine and talk to that application, right? -D is detached terminal because this is going to be a daemon application, so we're basically starting it up. I don't need to attach to the terminal, and then this is the container that I want to run. And so let's go ahead and get that cooking. 1, 2, oh, yeah, SQL Server's up and running already. That's that fast, right? It's as fast as it takes to start a process. And so I can ask Docker, like, hey, Docker, what are you running? Docker PS, right? So this is the running container. We get a unique identifier. It tells us what image we're running. It tells us the entry point or the command that we're running. It's been up. It was created 9 seconds ago, and it was up 2 seconds. So literally the startup time was 2 seconds to deploy SQL Server. It's listening on all IP on 1433, and it's sending the data inside to the container on 1433 and running SQL 1. So let's go ahead and talk to that application. I'm going to use SQL CMD to talk to localhost. It doesn't have to be localhost. I use localhost because I don't know what my IP is going to be wherever I go. So I specify localhost, but it could be whatever my real IP is, so anyone could talk to this machine. I'm going to talk to 1433, and I'm just going to say, hey, SQL Server, what's your name? Right, and it's up and running. I mean, I'd still be like waiting for the VM template to copy if I was doing this. I mean, I love VMware and all that, or virtual machines. I made a lot of money off of VMware over the years. I wrote a master's thesis on virtual machines.
Do all the containers on a host go and assume the IP address of the host?
Yeah. In Kubernetes, there's like a totally left-hand curve on that one. Let's talk afterwards on that. Yeah, there's a concept of an overlay network because of the, all right, don't get into it now. I'm going to run out of time. But yes, we'll talk about that. If we have time at the end, ask that again. That's a very good question. So let's do it again. Let's deploy another SQL Server. Docker run, environment variables, SQL 2. I obviously can't have a port conflict, so I'm going to specify 1434, right? It's just be the next door from a port standpoint. And I'm going to send it into 1433, run that same container. I just deployed 2 SQL servers, yay. Docker PS, we can see that it's up and running. So we see 3 seconds ago, 2 seconds ago, and we're up. SQL 2 is on 1434 on the system. Now this is a couple interesting pieces of information. Is that image is the source for both of those containers, right? So there's no additional overhead to store the second thing. I just start up a second process, make a new writable layer, and go. And so both of those will be able to leverage that source image as the source because they're read-only, right? And so we can go ask that server for its server name, and you can see that it is giving us back its server name. The server name is the container ID. That's more of an artifact of SQL Server. So to interact with this particular container, I can send data into it, right? Because this whole concept of process isolation has got its own representation of a file system inside the container. I have to go and I'm going to affect some change inside of the container. So I'm going to say Docker CP. I'm going to copy a backup into the SQL 2 container at this location inside the container. So I run that. And I'm going to just quickly restore it. I'm going to just inject in a SQL script to restore the database to bring it up and running. It takes a couple seconds. It's like awkward demo waiting.
Question. The SQL script that you have is just on your local machine, you're just executing that directly against?
Yeah. That's
Not
right.
pushing the script inside the Docker container?
Right.
Okay.
Yeah, this is local, going over the network via SQL CMD. I mean, over the network as a local host is a little, a little trippy, but yeah, it's local. You can copy it in and execute it, and because SQL CMD is actually inside the container as well. But what's the word I'm looking for? Philosophically speaking, it's kind of antithetical to what containers are, right? I want to stay out of the container, just let them run, right? So what I'm doing actually now is not going to be what I'm going to do right now is not what you should be doing, because we're going to go inside the container. So Docker exec can execute an arbitrary process inside of the container, and IT says attach it interactively to a TTY on my machine, which is going to give me a shell when I say run bin bash, right? So bin bash is going to attach their standard streams and connect it to my terminal here, and now I'm inside the container, right? And so inside the container, if I ask the container for a process listing, I'm only going to see this stuff, right? I see SQL Server always has 2 processes because of its architecture. We see my shell, and we see the fact that I ran a command. So these are the only 4 processes that the container sees, right? But this is running on an operating system that's got hundreds of processes running, but this isolation boundary is around it in terms of process, file system, which we've addressed, networking, which we've addressed, and some additional OS constructs like semaphores and shared memory spaces and things like that are all isolated. So this is the boundary around the thing, right? And so this is why we can run libraries and things like that without conflicting with the other applications, because they're going to be loaded into this run space or this container and not, cause problems for our neighbors in that sense. So inside of var opt MSSQL, if I just do a directory listing on an application, you can see that our wide world importers is there. We can see all of our databases as part of a standard SQL Server deployment are up and running. So let's not get caught up in the SQL Serverness of this though. So I'm going to stop the container, which is going to send out what's called a sig term to the process. It takes a second sometimes. Sig term is kind of like hitting Control-C on a process on Windows and shuts it gracefully down, right? There's other signals that you could do nasty things with, but sig term is a good thing. And so that's what happens when you do a Docker stop. So if I do a Docker PS, we'll see I have one container up and running because I told SQL 2 to stop, but that container still exists, right? The stuff that I changed, the database that I stored inside of there still exists, but it's in the writable layer of the container, right? So I can start it back up and consume it just by saying Docker start, right? Just boom, start the process up, and it's going to see it still has all of that state inside of the container. Docker PS, everybody's happy, and we could see both containers are up and running. I can use a technique called bash expansion because I'm lazy, and that's going to go ahead and serially run those commands, 1, 2, SQL 1, SQL 2. Docker PS, you can see that they're both exited. Exit 0 is good, right? Now, if I do a Docker RM, that data's gone, right? So that's like the key thing I want you guys to walk away with is that writable layer, don't store data inside of your container. I have some code in here too also for removing all containers. That can be potentially bad, but it's also potentially useful. That's why it's commented out. But the key fact that I want to point out now is that my images are still there. So I can instantiate new containers and get up and running fast, right? So Docker PS, nothing is running. And so to make a data volume, it's actually quite easy. The same command as before, inject some environment variables, give it a name, map the network ports. Now I'm going to define a Docker data volume. And we can address it by name, SQL Data 1. And so that's going to expose a resource from the underlying OS and put it inside the container at var opt MSSQL, right? And so let's go ahead and start that container and highlight all of the code I'm supposed to run. I'm still waiting for that VM. I should do that. I should have like a VM template, like a DSC deployment going on at the same time. I love DSC, dude. I don't want to give it a hard time, but it's just 2 different ways of getting things done. And so let's do the same thing. Let's copy it in there. Let's go ahead and restore the database again. And what we're going to do now is restore the database. I'm going to say, hey, look at the databases. I'm going to take that container, delete it. We're going to create a new one and put it right in front of it. But the one I'm going to put in front of it, that's 2017. I'm going to put a 2019 in front of it. Boom, we've upgraded SQL Server in a matter of seconds. And so let's go ahead and do that. So stop the container, delete the container. It's all good, though, because the stuff that I restored is inside the Docker data volume, right? It's not inside the writable layer of the image anymore. So if I go ahead and simply start my container back up, or actually, I shouldn't say that. I instantiate a new container with Docker run. I'm going to give it the same name, give it that location of where the data is, start up the image, but this time it's 2019, right? I'm still waiting for the CU to download, right, and decompress. What's that weird phase where it decompresses and then then it decompresses again when you download patches? I was a Windows administrator once. I know. This is going to take a second. I do want to point out that it's not all like happy all the time. When you upgrade SQL Server, there are certain things you have to take into account with regard to internal database versions. That stuff still persists. Like we're changing the state of the data externally. So the fact that I'm bolting on a new 2019 means I have to deal with the fact that I'm actually upgrading databases too. Do you have a question, Josh?
Yeah. So question on the data volume. Do you have to like instantiate that first before you go ahead and like call it?
You can, but I didn't. You can do it just like that. I didn't do anything special beforehand to declare that and run it. The question was, did I do anything special to pre-configure that volume? Nope. That -v SQL data 1 was enough to get it up and running. Yeah, thank you. And so I always forget, unless I'm in the audience. And then I'm like, why did you repeat it? All right, so we're consuming Docker data volumes from the local file system. Those can be external. Those can be NFS, iSCSI, Fiber Channel, Azure Cloud Files, Blob, things like that, right? So we can consume that if we need to. And by now, after I killed enough time, I have my databases back, right? So that was like, what, seconds to upgrade SQL Server? And the majority of that was actually SQL Server doing its own work, right? Cool. So yeah, Docker volume LS. I'm using the local driver. That's where you would see the different storage subsystems if you needed to consume a different storage subsystem. And this is where it really lives. Remember, Docker and the inspect command will be your friend because it tells you cool stuff. And we're all super nerdy. And so we know what all this stuff means. But we need to get into what is going on behind the scenes. So created at the local driver. And that's where the data actually lives on my file system. There's some special black magic that occurs on Mac OS running Linux containers. If you're running Mac OS on a Linux container, hit me up. We'll talk about it afterwards. But if you're running Linux on Linux, if you browse to that directory, you would see the files that were part of the file system from the container. So let's go ahead and stop that container, delete that container. And now if I do that, then my data goes away, right? What's that, a resume generating event? Is that what that's called? And so I also have some additional code in here to delete. So when you're working with containers, you're creating them and killing them and things like that. I just have some different scenarios, like you can searching for patterns and deleting the images and deleting the containers so that if you need to clean up when you're done, that's an easy way to get it done. That's bash specific. That would probably not work in other systems. So let's do PowerShell. What's up?
So the reason that image is only 1.5 gigs is because it was the Linux version of SQL, right?
Yeah, I haven't worked with the Windows version of SQL Server.
And then, is there any issue if you're like running Linux as the host, Windows as the image,
Okay.
and then Windows is, then the Windows
Yeah.
version? I mean, is there any issue trying to switch which
Yeah.
is running on which host?
Yeah, I think I'm with you on that. So the first question was, why was SQL Server so small at 1.5 gigs? Because it's SQL Server on Linux, right? And it's going to be the bare minimum of what it takes to run SQL Server. The cool thing about containers is this. The product team is not in the business of supporting an operating system. In fact, they consume, if you go look at the Docker file for SQL Server container, it says from at the very top. It says from Ubuntu. And so they're able to actually consume the work of Canonical and not have to get in the business of maintaining an operating system, right? They just deploy SQL Server on that. So they pull the container, make their changes, build their image, and go, right? Which is pretty cool. And you think you can leverage those efficiencies in your application so you don't have to get in the business of building operating systems. You can consume a Windows or a Linux container, build it, and go. The second question was with regards to running different container operating systems on top of a different actual operating system or host operating system. Yes, you can do that. In Windows, what winds up happening is there's a little tiny VM. You run Hyper-V, and there's a little tiny VM that runs inside of Hyper-V that listens to the system calls for Linux, and that does that work for you. Then Windows just talks to Windows. There's a whole other universe of containers with regards to isolation called Hyper-V containers. In this sense, some security administrators get sketchy on the fact that there's a shared operating system underneath and that there's not enough of a security boundary between the two. So you can actually run a really lightweight VM and instantiate multiple containers on top of that, and that's a Windows-specific thing. Well, all right, so we're on that topic. Then on the Mac similarly has, the kernel itself has like a little tiny hypervisor inside that's answering the questions for the Linux calls on my Mac, right? So when I say read this way, that's going to, when I make a system call, I should say, that's going to execute against the hypervisor, and it's going to be answered appropriately by the kernel on the Mac. There is some funny business with regards to that on certain database operations with regards to how files are opened for non-buffered disk access, but that's another conversation we can have afterwards. So let's shift the gear to PowerShell. Let's shift gear to PowerShell and get into this. Okay. So we have a couple containers. So we're all hip with what this means now. Docker pull, specify MCR. I want to pull PowerShell latest. I also have PowerShell 6.2. I let the cat out of the bag that they're actually the same image earlier behind the scenes, or PowerShell preview, right? I've already pulled all of these, so we won't go into that. And that's all, they're all cached locally on my machine. I do a Docker inspect. We can see inside of those that 6.0 or 6.2.0 is latest. If we go down a little bit further, we can see that there's no network stuff open. We saw that earlier in there, but we do see lots of environment stuff configured because PowerShell needs these things. To launch PowerShell, it actually launches binsh and then instantiates a PowerShell command on top of that. So let's go ahead and look at the bajillions of PowerShell containers that are available. This takes a really long time to run when compared to the SQL Server one, because there are that many platforms. So when we go through this list, when it pops up, we're going to see Server Core, we're going to see Windows, we're going to see Ubuntu, we're going to see Red Hat, CentOS, and every iteration of PowerShell since then from a release standpoint. So 6.0, 6.01, 6.02, 6.03, and all of the releases between. So if you have to test code against a particular version of PowerShell and you find yourself installing PowerShell and not going Docker pull first, please come talk to me, and we'll go over this again. Request cannot be served. All right. Trust me that that's going to be a big list of really cool stuff and run your code later. I do have a video of this, but this is not quite that bad of a demo fail to go into that territory yet. So we're going to instantiate a Docker container running PowerShell, right? So Docker run, give it a name, interactive TTY, which was -IT in the previous set of demos. I just expanded it out for you this time. And because in this case, we do, oh man, it's one of those things. All right, there we go. I forgot to get out of PowerShell. And so Docker run starts up PowerShell. IT attaches to the process. I now have PowerShell running inside of a container. So when I do this, I see that, right? It's the only thing in the universe that's running inside of this container. Or at least that's what my application thinks, right? Process ID 1, PowerShell. Similar concepts as before, data persistency still has to be maintained. So if I write this out and I go ahead and I want to look at that data, it's there for now. If I get out of the container, this is where it's going to be different than looking at what we had on the SQL Server side of the house. SQL Server is a daemon, it's up and running, right? So when I exit that application and left the container, it stayed up and running. But in this case, when PowerShell exits, it actually terminates the container because it terminates the process. SQL Server doesn't do that, so I don't have the running container anymore. It still exists, right, instantiated. So everything that I have inside the container, inside the writable layer, still persists inside of that particular container. So I can bring it back online if I want to with Docker start, just like we did a minute ago. And I'll attach -i because I want to interact with it or attach to the terminal. And so there's my stuff, right, that exists. And so we go ahead and get out of the container with an exit. Until now, it no longer exists because my data is gone. It's part of the writable layer. But this is where things are going to get cool. And I think hopefully this kind of connects these things and how you guys manage your operations, because we can do stuff like this. I can say Docker run, instantiate a container, and then run a command right away and do some work. And so that's going to go ahead and start up the container, run PowerShell, and shut the container down. All right, and that's that's fast, right? Think about that from a deployment standpoint. And I can also control specific versions. So I go back to 6.2 if I want to, or I can even go down to, or go up to preview and run 6.2.1 or 6.2.0 RC1, right? And kind of get that, I can basically test this stuff, not having downloaded PowerShell, extracted it, put it in the right place, changed the environment variables, and done all of that work, right? I can just go and run my code. But in this case, when I'm doing all of these things, those containers come down, they start up. I'm like, yeah, I don't have to like clean these up and like write weird regular expressions to go sniff these all out. And so all those were instantiated and ran and persist as containers. And so I have some scripts here that go and delete all of that for you. And now let's go ahead and do this one more time. But this time I'm going to attach a volume. And I'm going to go ahead and I'm going to copy a script from my local machine into the volume. And so this is literally just like we did with the backup. I'm going to copy it into a fixed location inside of a container that I named PowerShell script that I just started. And then I'm going to kill that container. but that still exists on my local machine. And so now, if I go and I start up the container again, my scripts are in there, right? So I can build this little repository of things, or however I want to get scripts into that Docker data volume. And I can run that script in my container and do the things that I want to do, right? And then delete the container. But why would I want to go through all that? What if I want to just do that all in one shot? And I can do that. Docker run. I'm going to add the -rm parameter now, and I'm going to attach it to that volume and then run that script. 1, 2, 3. So basically, you guys know how serverless platforms are built, is that. Instantiate container, run a script, kill the container. And the overhead of that is trivial, right? Because I'm starting a process. I'm executing the code. In fact, the majority of that execution time, I'm not going to make fun of PowerShell, is PowerShell. But it is what it is, because it's got to do the things that it has to do when it starts up. You know what I mean? So I'm not trying to be funny, or like not nice on that one. And so that leaves us with some stuff, right? And we looked at stateful applications, stateless applications. We built a serverless platform, functions as a service. We can inject code, functions, whatever we want. But that leaves us with some challenges that we have to solve in terms of things like workload placement. So if I have a data center's worth of computers, where do I run this thing? Like, do I want to get in the business of starting SQL Server here and attaching a volume and exposing a network port, or instantiating a container, attaching a volume and telling it to run a script? I don't want to get in the business of doing that. Right? So there's things that help me do that. So workload placement. And so these are the things that container orchestration does for you. They also manage state. So the fact that my containers are stateless and I'm storing the state of those things externally means I can just kill it and redeploy it. So if SQL Server or whatever application I'm running crashes, no big deal, because I know I go back to that beginning state every time. I assert the configuration externally, which means I can kill this thing and redeploy it. Right? And that's a total shift in paradigm in how we roll out applications and services. Container orchestrators provide arbitrary trivial load balancing for IP services, so I can basically stand up a web farm with 3 clicks of a mouse. In fact, the last time I did a Kubernetes demo, I went from 1 to 50 containers running an application in 1 line of code, right? And if you've ever done that in a real data center, that's more than 1 line of code. It handles networking. We talked about TCP ports and things like that. Persistent storage, and the fact that we don't want to get in the business of managing where our storage comes from, especially in the cloud. I want to be able to build infrastructure agnostic platforms and just say, I want to consume some storage from my cloud provider. And so container orchestrators give you that for you. And also a declarative model, right? Conceptually, we don't want to get in the business of imperatively configuring these things. We define code that describes the configurations that we want. We push it into the container orchestrator, whichever one that is, and that makes that happen for us. And we talked about job distribution already. Container orchestrators have the ability to execute work if you just tell them to do things. I want you to run this script on this container, go, and it'll do that for you. And we can also do secrets and certificate management. So we can even go one step further with that PowerShell container and use remoting from that container to then go through, pull a certificate down, and start logging into other machines. And security administrators will be very happy with you after that, because the container then deletes and goes away, and no one knows what happened. And so, yeah, I was in Ashley's workshop the other day, which was fantastic. And I was like, and we were going through all the logging stuff. And I was like, that's cool. I'm like, hey, check out this line of code. He's like, man, really? And so, container orchestrator. So these are the big players in the container orchestrator universe. Docker Swarm comes from Docker. Kubernetes is an open source container orchestrator. They effectively do the same thing, but it's kind of like VHS and beta. One of these won, right? And one of these, it didn't win. And the one that won was Kubernetes, right? Red Hat OpenShift is a for sale version of Kubernetes. So if you're in the kind of shop that needs to call 1-800-somebody to get support, you're going to go with Red Hat OpenShift. I think the reason that Red Hat was acquired by IBM is solely for that alone, because that was their Kubernetes cloud play, and now they have one of the biggest products to do it. From a managed service perspective, AKS, GKE, EKS, right? These are the big players. You can go and consume Kubernetes right now. If you have Docker on your laptop, you can have a Kubernetes cluster in one checkbox, and you'll have all the stuff that you need to do to run developer level versions of Kubernetes or developer implementations of Kubernetes on your laptop. You go into the properties, there's a little Kubernetes icon, check the checkbox, it'll pull the containers down, you have Kubernetes. And a container orchestrator. So I think did we cover a lot? Is that a lot? Yeah, okay, cool. All right, we introduced containers. Who knows what a container is now? Who doesn't? Let's go have beers. Right. You two guys. Who's going to go run PowerShell in a container by the end of today? I thought that was pretty cool. Like because I wrote these demos a couple weeks ago, and I was like, that's not going to work. And it did, right? And I think it's really fun stuff. The container universe, we talked about Docker, Rocket, CoreOS, and things like that, Kubernetes. And we did lots and lots of demos. Like I said, I'll post the demos at the end of today. And we learned what the concepts behind container orchestration. Contact info, if you're not familiar with the Linuxy stuff, I have some Pluralsight courses. I'm not trying to sell you things. I have free cards up here. If you want to get access to that content for free, hit me up and I'll give you a free card because I want you to be able to get up and running with these technologies and techniques ASAP. From a resource standpoint, I didn't cover installing Docker because on Windows, it's next, finish. On Linux and Mac, it's really straightforward, but if you want some docs, those are there, and also getting started commands. Storage is a big deal. Spent a lot of time there getting started and have some security stuff there. Please eval the session. I only accept 5-star evaluations, and so go ahead and make that happen. But thank you for everybody for coming.